Let's go solely code 624. Maximum distance in array give us m arrays, and each array is sorted in ascending order. So you can pick up two integers from two different arrays and calculate the distance. We define the distance between two integer a, b to be absolute difference is a and b. Return the maximal distance. So that means we need to select um, two values from two different lists, and want to have a maximal difference. So that is that if we know these kind of arrays, they are in ascending order. That means if we find, for example, the largest and the smallest, if these two values, right? Because they are in ascending order. What we need, we just check the last element for the maximum, and check the first element for the minimum. And if the last and the max and the minimum they are in the same list, right? Then we should still consider the second smallest and or the second largest. In that case, we need to have if the max and the mean they are in two different lists, we just return the max minus the mean, right? If they are in the same list, then we should can compare the max minus the second mean, and also second max minus mean, right? Compare the biggest between these two. So we need to get a iterate this kind of arrays, right? And find the max, second max, mean, second mean, and max one, for example, max one index, max two index, mean. Let's call largest one, largest two index, smallest one index, and smallest two index, right? So we're just trying to see what the largest one index equals smallest one index. If they don't equal, just use max, the largest minus the minus smallest, right? Otherwise, we need to have compare these two, right? So let's write code for this. We know there are m arrays, and m equals arrays of length size. So we are going to do is that we need, for example, the largest, right? And let's set a largest as integer dot minimal value, and the second largest let's set as integer dot minimal value, and the largest index let's set as -1. Second largest index let's set as -1 as well, right? And the smallest value, right, should initially set as integer dot max value, and the second smallest equals integer dot max value, and the smallest index was -1. Second smallest index was -1, right? So what we do is that we just for int I equals 0, I smaller than m, I plus plus. So we're going to have a list of integer list equals arrays with I, right? So we know for this list, because they are sorted, so we know current smallest will be list get 0. And the current for this list is the largest one will be list get list dot size minus 1. So what we do is that if the smallest is smaller than current smallest is smaller than smallest, global smallest, then what we do is that we need to have second smallest ID use S equals smallest ID, and smallest ID equals I. And we are going to have second smallest equals smallest, and the smallest equals current smallest. Else if current smallest is smaller than second smallest, right? Then we are going to have second smallest index equals I, and S2 equals current smallest. And also, we say if the current largest is greater than global, the largest value, right? Then we're going to have second largest ID equals largest ID, and largest ID equals I. And also largest, the second largest should be largest, and largest will be current largest. And else, if current largest is greater than second largest, then we're going to have second largest ID equals I, and the second largest equals current largest. So doing like this, right? Then what we need is we compare if the largest ID doesn't equal to smallest ID, we just return L1 minus S1, right? Because that means they are not in the same list. If we go to, for example, line 31, right? That means largest and smallest, they are in the same list. Then that means largest and the second smallest, they must not be in the same list. And the second largest and the smallest, they must not be in a list because the largest is in the same list with the smallest, right? So now we can just write max dot max largest minus second smallest, and the largest 2 minus smallest 1, right? Okay. There are m arrays, so we'll see. We just use we iterate I from 0 to m and get a current largest and a current smallest. That is just O1 operation, and those kind of operation that is also constant. So the time complexity just OM. M is the list numbers, and space is a constant. Convert this to Python code should be very similar. So we are going to have M going to have L1 ID, L2 ID, L1, L2, smallest ID, second smallest ID, smallest value, and largest value, second smallest value, right? So they are going to be equal length arrays, and this one set as -1, -1, and followed followed -9 f, right? and also -1, -1, float IF, float IF. So we just do for I in range M. We are going to current list equals arrays I. And we know current smallest is current list 0, right? And the current largest is current list the last element. So what we do is that if the current smallest is smaller than the global smallest value, right? Then we're going to have smaller 2 ID equals smaller 1 ID, and smaller 1 ID equals I, and smaller 2 equals smaller 1, and smaller 1 equals current smallest. And we'll say else if this one is smaller than second smallest, right? Then we're going to have S2 ID equals I, and we're going to have S2 plus current smallest. And we're going to write if current largest is greater than the global largest, right? So we're going to have largest 2 ID plus largest 1 ID, and largest 1 ID equals I, and also largest 2 equals largest 1, and the largest 1 equals current largest. Here, the order, we should set L2 equals to L1 first, right? Do not mess up the order. And write else if current largest is greater than L2, right? Then we'll have L2 ID equals I, and L2 equals current largest, right? So this is just iterative one pass. So what we write is if L1 ID doesn't equal to L2 ID, that means the largest and smallest they are in a different list. So just return L1 minus S1, right? Otherwise, that means the largest and the smallest they are in the same list. That also meaning largest and second smallest, and second largest and the smallest, they must not be in the same list because the largest is already with the same with the smallest, right? So we just return max L1 minus S2, L2 minus S1, right? Let's take a look. This is smallest. So if current smallest is smaller than smallest, then S2 equals, otherwise S2 is smaller than second smallest. Then second smallest ID equals I, and the second equals, if current largest is greater than global largest, then this is correct. L1 equals current largest. Else if current largest is greater than second largest, then so this should be S1, right?